In this video, we are going to take a look at OSPF version 3. OSPF version 3 is going to be the routing protocol used to intake and build in the IPv6 stack and be able to allocate it. OSPF version 3 is compatible with IPv6 OSPF. The only difference between the two is with OSPF version 3, you're actually able to run both address families at the same time under the same routing setup, instead of having to have router OSPF 1 for IPv4 and IPv6 OSPF, or IPv6 router OSPF 1 as well, or I believe it's 2. But regardless of the setup, this gives you the ability to go in and manipulate both address families at the same time from one configuration setup. So from the global process, you're able to go in and manipulate certain things. The bulk of your configuration, though, will be done at the interface level. So we won't have to worry about trying to go and advertise routes and stuff like that. So in OSPF version 2, or if you were to go in the address family for IPv4 under OSPF version 3, you'd be able to advertise the routes with the network command. But remember, you're not actually advertising routes. You're turning the OSPF process on an interface that matches the network statement, and therefore that's going to send and receive OSPF hellos to form adjacencies. So that's going to be the basic overview of how that actually works. So the nice thing about OSPF version 3 is there's a lot of things that are similar to OSPF version 2. It still uses transport via protocol 89 to unicast and multicast for unicast and multicast traffic, but it multicasts to FF02:5 and FF02:6. FF02 anything is going to be multicast, whether it's link local or FF02 is link local. So as you're going through, that's going to be a clear indication that what you've got going on in your environment. We won't be looking at IPv6 multicast. I will give you guys a quick high-level overview of IPv4 multicast and kind of an idea of how that works. Same thing with some basic quality of service towards the very end. But that's going to be the generalized breakdown to how this stuff actually works. Normal OSPF rules still apply, so adjacency parameters and OSPFv3 network types. And then the only difference is when you're dealing with your EUI64 format for interface IDs, you're going to start out with the FB80, and it'll be : and then it'll take whatever the MAC address is. And I'll show you what that looks like, and I'll break down the universal local bit just to give you guys an idea of how that would actually look. Two new LSAs are actually joined inside of OSP version 3. We have the link for link local addressing, which is a type 8, and we have type 9 for intra-area prefixes. So basically, this is I don't want to say a replacement, but it's the similarity to how your type 1 and type 2 LSAs would work. So in a type 1 LSA, that's going to be the router LSA. Type 2 is going to be the designated router. So if you're receiving these routes in, that's going to be pretty much how you're going to be able to dictate what's going on in the network inside of your area. Because once you hit an ABR, you automatically flip over to type 3 LSAs, which is going to be the network summary, and the summary link state, and that's going to give you an idea of where you need to be heading for your routing. So, because remember, when you're dealing with an OSPF, if there's a reconversion somewhere inside that area, that information is not flooded to other areas because the area border router prevents that from happening. So if you need to reach another area, you're going to reach an OSPF border router, and then that area border router is going to be basically your area default gateway to getting into another area. So your next hop is going to be set to the type 3 LSA in the header. When it comes down to configuring OSPF, it's actually very, very simple. There's not a whole lot there to it. It's, like I said, everything's done at the interface level, and once you've turned IPv6 on globally, and you have an applicable IPv6 address configured at the interface level, then you can start forming OSPF adjacencies. So I'm going to go ahead and show you guys how to set up the adjacencies. It's actually very, very simple to do, and I'm going to go walk you guys through how that is actually set up right now. So there's our adjacency, or that's our topology. I'm going to pull up PuTTY, and I'm going to take you guys over to router 2 and router 7 are going to form an adjacency with each other. And I'm going to go to global config, and on router 2 I'm going to type in interface Ethernet 1/0. I'm going to type in OSPF version 3 question mark, and we have the process ID. This is what you have to do this before you do anything else. So process ID 1 question mark, and then what address family do we want to specify underneath the interface? IPv4 or IPv6? I'm going to type in IPv6 question mark, and then what area do you want to place inside of? So area 0 in our case. We're going to hit the enter key. Okay, I don't have IPv6 in IPv6 unicast routing working yet. So I type back in interface Ethernet 1/0, hit the up arrow a couple times, and there we go. So now if I type in do show IPv6 interface brief, or I'm sorry, end of the line. Do show OSPFv3 interface brief. There we go. So now we have that, and we're going to go to router 7, and I'm going to go type in global config do show IPv6 interface brief. We don't have actually an IP address configured yet. So what I'm going to do is I'm going to go under interface Ethernet 1/0, and I'm going to type in actually I need to come here and type in IPv6 unicast interface Ethernet 1/0 and type in IPv6 address question mark. Now see this auto config here? This is where that comes into play. I can type in auto config, and I can then hit the enter key, and then it's going to take whatever the MAC address is and form it. So do show IPv6 interface brief. As you can see now, I have a I've actually, because I had the I don't remember putting that there, but it says 2100, and then it grabbed this address. So that's completely okay. I'm alright with that. So what I'm going to do is I'm going to go, since I'm underneath the interface, I'm going to type in IPv6 question mark. I'm going to type in OSPF question mark, and it's going to say, what's the process ID? We're going to hit 1 question mark, and we're going to say, what's the area? The area is going to be 0. And that's all there really is to it. So we should form an Ospf adjacency momentarily. There we go. It's when you're dealing with classic OSPF is when you run into problems. So if you were to go to OSPF, like if we were to run on router 1, for instance, if we were to go here and type in show IP protocols, we're not running any protocols. But if I was to come up here to global config and type in router OSPF 1 and type in network of 10.1.100.0 0.0.0.255 area 0, and if I was to go over to router 2 and go to since I'm underneath the interface, if I was to type in OSPF version 3 1 IPv4 question mark and area 0, do show IP interface brief, even though I have an applicable address and I can ping, so do ping 10.1.100.1, and I can ping it, what I won't do is I won't form an adjacency. And the reason for that is because the fact that OSPF classic mode and OSPF version 3 are not compatible. So you can be running IPv6 OSPF here and IPv6 OSPF version 3 here, and it'll form an adjacency like we just saw. But if you try to do classic OSPF here and OSPF version 3 here, it's not compatible. At least in my experience, it's not. So we type in do show IP OSPF interface brief. You'll see that it automatically grabbed the DR, right? It's the DR. If we look on router 2, we type in do show OSPF or OSPF version 3 interface brief. Here we have on Ethernet 1/0 for IPv4. It says we have no neighbors. It's not forming the adjacency, right? So we don't have that capability to join. So it's not going to work. So if we wanted to join via OSPF version 3, we'd have to actually remove this config here. So I'm going to go to router 2 and hit the up arrow and pull that config out. And type in no. I'm going to type in IPv6 OSPF and we're going to say 1, and we're going to say area, or I'm sorry, not OSPF there. We're going to type in IP OSPF 1 area 0. Now it will form an adjacency, because now we've gone back to OSPF version 2. Now if I was to pull that config out and flip over to router 1 and type in OSPF version 2, or version 3 at the interface level, router 2 and router 1 would form an adjacency. So if you are looking to migrate to a dual stack environment and you are running OSPF version 2 and you want to place in IPv6 OSPF, you can do it, but you have to work with compatibility. If you are doing a green deployment, so it's brand new, I would recommend running OSPF version 3, because then you can specify the address family in your configuration, rather than having to work with the compatibility in that regard. So that's pretty much how that gets going. So now let's take a look at some of the other configuration that's available here. If we type in OSPF version 3 question mark, and we have a couple of options here. Obviously, bidirectional forwarding detection, specifying the cost, the authentication capabilities. We also have encryption, but that is only for IPv6. You cannot use encryption for IPv4 traffic. Flood reduction for minimizing hellos. We have the MTU ignore if you're having to deal with MTU mismatch. That's good in lab environments, but I would never recommend doing that in production, because if there's an MTU mismatch and you're trying to send more than what the receiving interface can take, then you can actually take down the adjacency. We have the neighbor command for doing unicast adjacencies. We have the network command for advertising the network type, so whether it's point-to-point, non-broadcast, whatever. This is not actually advertising a route, it's changing the network type. And depending on the network type, so if you choose non-broadcast or broadcast, it's automatically going to have a DR election. If you do not have a configuration set up for that, then it'll be, if you choose point-to-point, point-to-point non-broadcast, or point-to-point non-broadcast, or point-to-multipoint non-broadcast, then it will have no DR. So if we were to look on for here, if we were to type in do show OSPF version 3, do show OSPF version 3, let's go interface brief. We're going to have an adjacency just to router 7. It doesn't tell us who we have, but we could say we know that, or actually if we were to type in neighbors, we know we have a connection to router 2, or I'm sorry, router 7. And then we know that's working. So now what we could do is we could go, and if we were to take a look at show IP OSPF interface brief, we know we're going to have a connection to router on router 2, router 1. But if we were to take this and type in neighbor, we'd have to type in both commands, and we have a connection to router 1. So you'd have to see how you have to flip back and forth between version 6 and version 4 to find out what's going on. So now if we were to go and add in, say we're running OSPF version 3 here between these guys, if we were to go to router 6 and go to global config and type in IPv6 unicast routing, and go to the interface level, type interface Ethernet 1/0, and type in IPv6 address family, or IPv6 address is going to be auto config, and type in do show IPv6 interface brief. We have the 2001, and then we basically what we do is we take what the other guys are advertising to us, which is the 2001 100 address, and then from there what we're able to deduce from there is we simply just add in our MAC address as our link local address. Now what I can do from here is I can type in OSPF version 3 1 IPv6 area 0, and then I'm going to form an adjacency with router 2 and router 7. There goes router 2 and router 2. So now if I typed in do show OSPF version 3 neighbors, I'm going to have 2 neighbors. If I type in interface brief, I have the connection there. I'm a DR other, because 2 and 7 have already determined what's going on. Router 2 is the DR, router 7 is the backup designated router. So as you can see, a lot of similarities with setting up your config. So it just depends on how you want to go about doing it and getting everything operational. So that's pretty much that's pretty much how OSPF works. The only thing different here now, since I'm under OSPF version 3, if I was to go to router OSPF version 3 and hit 1, now I type in address family IPv4. Let me show you a little something real quick. I was just doing here, you know what's not here? What's not here is the virtual link. And you're like, wait, what? The virtual link is not available under the IPv4 address family of OSPF version 3. Now, if I was to go to router OSPF 1, it would be available. So if I typed in router OSPF 1 and I do a question mark, guess what's if I take, sorry, let me go back to this guy, and if I type in area question mark area 0, I'll say area 1. Notice what's not here. I don't have the ability of configuring a virtual link. But if I was to go to router OSPF 1, type in area question mark area 1, what is available? In OSPF version 2, you are allowed to configure a virtual link underneath IPv4 as well as IPv6. Now, if I was to go type in router OSPF version 3 1 and type in address family IPv6, type in area 1 question mark, it is available under IPv6. It is not available under IPv4. So that's going to be a key difference when you're going through your configuration, is to know that. But beyond that, that's really that's the only major things that I've seen that are not available, which are, in my opinion, are negligible in the greater good. So everything else, literally everything else that I've shown you for OSPF is the same. There's a few minor caveats with some other details, and those are so negligible. Like with IPv6, you can say, for instance, we were to go to interface Ethernet 1/0 and type in IPv6 or IPv6 OSPF 1 question mark area 0 and do a question or IPv6 IPv6 OSPF. The same configuration is available under IPv6 OSPF as OSPF version 3 because they're both the same protocol at the end of the day. It just happens to be that OSPF version 3 I think is easier to work with because it's all under one address family or one major protocol, and then you can go into the address family as you need to. So that's pretty much all there really is to it. Authentication is the same. The only difference here with V6 is you have the ability of doing encryption. I'm not going to show you guys how to do that because I think that's outside of the scope of the exam, but just be aware that you can do a one-hop IPsec tunnel between there. So if we were to type encryption, we'd be able to type in we could type in IPsec, and we could use SPI, which is our Security Parameters Index 256, and use ESP as the encapsulation. We could use use ESP with no encryption. We're going to use a null and SHA-1 authentication, and we could type in our character string, which is going to have to be 40 characters, which is it's a lot of content. So it really takes a lot of configuration to get IPv6 encryption working for OSPF. I don't recommend, you can play with it and test it out. I don't think it's really applicable unless you need that capability. So that's like the only advancement that I can think of that is applicable for our exam. But beyond that, that's pretty much all I wanted to show you here with that. And since I'm already on the topic, I'm actually going to bring up redistribution while I'm here. So we're going to type in router OSPF version 3 1 and type in address family IPv6, and you see the redistribution keyword right here. Redistribute, we'll say EIGRP, or we'll say BGP. We'll type BGP 1267. That's what we're going to be typing in anyway. The thing with when you're typing in redistribution, you'll have to specify that you're going to be doing include connected. And the reason why I say that is because when you're dealing with that, you'll have to specify that you're going to include connected routes. So we'll type in the metric subnets is not applicable here. It's not under OSPF. It's under BGP. So router BG. We're going to do BGP anyway. Or I'm sorry, router. Router 2. I want to do it there. So router BGP 1267, and we're typing redistribute OSPF version 3 question mark 1 question mark and we're going to have to specify a match. There we go. That's what I was looking for. The match, internal and... I'm sorry, it's not this one. If we were to do redistribute connected, I don't... It's weird because I'm not seeing the include connected command, where include connected would have to be mentioned in order for you to bring in the connection. So we're redistribute OSPF, we'll say regular OSPF, process 1, match, yeah, that's not what I want to do, a route map, test, and then match. Yeah, see, what's not showing up, and I'm not sure why it's not coming in, is the include connected command. Depending on the code you're running, include connected might be needed in order for you to do that. Because what include connected, by default, in IPv4 OSPF, or I'm sorry, in IPv4 redistribution, if the connected interfaces matched whatever protocol was running on them, so if you had OSPF running, and a network command included a route that was connected, which obviously it would, I'm trying to think of how I want to explain this. If you match something that's matched in the interface, what you'd actually have to do is you'd have to make sure that it's going to grab the protocol interfaces as well as anything that matches it's connected to you. In IPv6 it doesn't do that, at least in the way that this is showing up. So that's basically the idea behind how that would work. So by including the include connected command, which is not here, and I haven't been able to find it here, so I'm not sure why it's not showing up. But they may have removed it because this is the service provider track configuration, so it might actually do it by default. But I know in other code you have to use the include connected command, and that's where it comes into play. If you don't match the include connected, or if you don't specify the include connected command, anything that's connected to you won't be advertised. So if you need to do that, then that's going to be a situation you're going to have to make sure you're aware of to get everything operational. So just be familiar with that. I'm not really going to do anything redistribution here, as long as because redistribution is identical here as it is in IPv4, and I don't know what redistribution they might have you do in the exam, but just remember that when you are doing redistribution, and you have, let's say 7 is redistributing BGP, so we have BGP running here and OSPF running here. If you redistribute OSPF into BGP, and you redistribute BGP into OSPF, that anytime the traffic, and let's say you're only doing mutual or two-way redistribution on a single router, when you advertise the OSPF routes in, you're going to place the router ID of router 7 inside the OSPF updates to the other routers. So if you try to advertise a route back out to router 7 from you or from another router, and you see your own router ID come in as in the update, you know you advertised that route. So therefore the route is going to be dropped. It's a loop prevention mechanism. Well, if you have mutual redistribution here and mutual redistribution here going in this way, this is where you can get into trouble, because you can be learning a route in this way and learning the same route in this way. And if you do that, what's pretty much going to happen is they're going to cancel each other out. And the idea here is, and that's not always going to be the case. So what I mean by canceling each other out if you learn a route in this way and then you come up here and you advertise it out this way, then you could potentially have asymmetric routing. It'll still function, and I'm thinking about that before I want to go any further. There will still be functionality, and without having labbed it up, I'm not 100% sure if I'm spot on with that, but it is possible to do asymmetric routing. So you're doing mutual redistribution on both ends, but the problem that could run into play is you can get a loop at the same time. So you can go back in here, I'll say the next hop, it's the ISP, and then the ISP is redirecting this way, and then you end up doing one of these numbers. That is also a potential problem. So the best thing to actually do here, and we'll just go here, we'll say we're doing this, and we're doing mutual redistribution. I figure I might as well just cover it while I'm right here. The idea here is, when you're setting your redistribution up, you want to make sure that if you have two edge routers connected to the internet, it's actually better not to do redistribution. And I don't really see a value, I shouldn't say I don't see a value, but in most environments there's no reason to redistribute. Now you can redistribute if you'd like to, but there's really there's no real reason to do so, because you can advertise routes out and not even have to bother with redistribution. The only time redistribution comes into play is when you want to bring one protocol into another protocol. So if you bring OSPF routes into BGP, you have to redistribute. And that's one-way redistribution. But you can do the same thing with doing the network command under BGP. That's why they give you that capability. So I would be using redistribution carefully in your environment, because you can run into routing loops very, very easily. So when router 2 receives a route update in, whether it's for a BGP route or whatever the case might be, the router ID is automatically injected into the routing update. The routing update goes out. These guys learn it in, right? So the traffic comes in, he learns it in from router 2, everything's great. He does the same thing. He learns a route in, he propagates it to router 2, router 2 learns that in, he learns his router ID, everything's good. However, when you're dealing with that, just because you see the routing update come in doesn't necessarily mean that you're going to identify it as something you've advertised. That's why you have to be careful with this. So normally what I do is, if I have that going on here, I will only allow certain routes to be propagated from certain routers. So for instance, if I have this router doing, say it's just doing BGP internet. So I have a default route from the provider for all of my internet, and I'll redistribute, or I'll do some sort of default routing to this router for all the internet traffic. Okay, I have that going on here. And let's say router 7 is my MPLS router, connects to the provider, and I'm advertising a bunch of routes here. So what I would do is my longer match stuff would go this way for all of my private WAN going over MPLS, or the newer one out there is this thing called iWAN, which is basically VRF-aware DMVPN with PFR version 3. So there are capabilities out there to get really granular with your deployments. I've never actually played with iWAN, but I have a friend of mine who's a CCIE that he's basically the iWAN guru for his company, and he does iWAN deployments all the time. So he actually he thinks very low of MPLS because of what iWAN can do. But I'm kind of the opposite way, because I work with MPLS every day. So, but the idea here is, if you do have routes that are propagating, you want to make sure that you're propagating them correctly. So by filtering would come into play. So knowing how to filter routes is a big deal. That's why I showed you guys how to do that early on. So I've already shown you guys in an IPv4 how to redistribute. It's very, very simple to do. I don't think we really need to go into a whole lot more detail on that other than what you've seen. Just make sure that if you are redistributing, that you are, and you have, if it is possible, learn in the same route from two different places. So let me actually pull this away here real quick. If you can learn, let's say you're learning if you're learning the same route from two different places, and you don't want that route feedback to come into play. Route feedback means router 2 learns it, advertises it to router 7 advertises it back over here, and then you can have a potential routing loop. In order to prevent route feedback, it is best practice to tag those routes. What I mean by tagging those routes is, you would go in and you would set a redistribute statement in a route map, and you would set a tag. The idea here is when you set the tag in the route map, you were saying for every route that's redistributed, it's going to have this tag associated to it. Usually you're going to call a prefix list. So the idea would be you'd have your route map statement here, and above that you'd actually configure a prefix list with the that's going to equal the allowed routes. And then you'd say, you know, allowed routes, and actually allowed routes. And then you would say for your match statement, you would say you're going to call the prefix list, and you're going to set the tag. The tag is set, and when routes are redistributed from say BGP into OSPF, wouldn't recommend doing that, but you could. What can end up happening is when router 7 learns those routes in, if you do a show IP route for whatever you learned from router 2, you're going to see those tags. It'll actually show at the very bottom of the output. What I would recommend you do then on this side is from the routing process, you would have underneath the global process, you would say a filter that would say deny tag, and you would go from there. So you could actually configure an access list at this interface and say match tag, you know, actually no, you can't do an access list, even though it's a data plane filter. Is it deny tag? You would configure a route map underneath the process. I'm sorry. You configure. I was thinking about you could. Oh, it's a data plane filter. You can or data plane tag. You would configure this underneath the process, and you would set a route map statement for say this first one's going to be 10 by default is what the route map sets it up as. And then you would say on router 7, you would have a sequence of 5 that would deny tags that are coming from 2. So let's say you matched everything. You set a tag of 2 here. So everything gets set with a tag of 2. Okay, and then that's from router 2 going to everybody. Then on router 7 you'd set a tag of 7 to indicate came from router 7. And then on 2 and 7, on 2 you would say a deny or negative on 7. So if you receive 7, any route with a tag of 7 on it, you would deny that. Same thing here, you say a negative 2. You would say I want to deny any tags that have 2 in them. If they have a 2, I want to drop them. And then you would allow everything else to go through. So that's a general idea of how you would do that. So you would prevent route feedback. And that's the most common thing I see in production environments today. You could also do a prefix list filter to where you would only allow out certain traffic via prefix list. There's multiple ways of handling the traffic, but ultimately if you I don't know what the topologies are going to look like for your redistribution when you get into the redistribution sections of the exam, if they're even going to give you any. I honestly don't know. They did in my exam. There was redistribution, and it was really easy to solve. I'm not going to tell you how I did it, but basically I kind of already have without actually telling you. But it's important to understand how the technology works and then go from there. So that's pretty much what I wanted to show you. And to answer the question that just popped up, I'm not actually going to be doing redistribution here. The point that I have set up for all this, for going further here through when we get finished with IPv6, and then we go into our services and security, what I'm going to do is I'm going to have OSPF here and BGP here. So it's going to be O routes. O is going to be here, and we're going to have BGP in between here, and BGP here, and BGP here, and then on here, and or actually I should say on here and on here we're going to have EIGRP, and EIGRP is going to be running on this side, and we're going to be doing NAT. We're going to be doing some other capabilities that are out there, and go from there. So that's a general idea of how we're going to get stuff advertised and go from point A to point B and get everything operational. So I hope this has been informative for you. I'd like to thank you for viewing.